It is not a single unchanged river that has flowed the same way for 400 million years. What persists in Central Australia is something more profound than that. A stubborn, deep-time drainage pathway that has been reborn again and again, while the continent around it rose, warped, weathered and dried out. That pathway is the Finke, Larapinta, and it is widely regarded as the oldest river system on Earth because its course has outlived entire mountain belts, ancient climates, and even the age of the dinosaurs. Long before a single T-Rex walked the planet, a line of flowing water had already been written into the heart of Australia, and that line is still visible today, etched across the Central Ranges as if time itself could not erase it. From above, the Finke looks wrong. Instead of weaving politely around the MacDonnell, Krichauff and James Ranges, it slices straight through them, carving deep gorges across hard quartzite ridges that were folded into place during the late Paleozoic. That geometry is the first hint that this is not an ordinary river. Most rivers are young, opportunistic and easily diverted. The Finke behaves like something older and more determined, a drainage system that has been burned in to the crust over hundreds of millions of years. Its story begins during the Alice Springs Orogeny, between roughly 400 and 300 million years ago, when Central Australia was being squeezed, folded and thrust into a chain of ridges and basins. To the north lay the ancient Arunta Block, to the south the deforming Amadeus Basin. As mountains rose, vast alluvial fans spilled southward off the growing highlands. Somewhere in this tumultuous landscape, a south-flowing drainage corridor became established. Whether the Finke existed in some recognisable form before the orogeny is uncertain. What is clear is that by the time these mountains were rising, a river line was already there, and it persisted as the ranges grew around it. That persistence was not passive. As the MacDonnell Ranges were uplifted, the proto-Finke cut downward at roughly the same pace, carving through rising ridges rather than being deflected around them. This process, antecedents, explains why the modern Finke Gorge looks like a river that shouldn't be there. The land rose, but the river kept pace, slicing its way through vertical beds of quartzite, Larapinta group sandstones, and Morini sandstone. After the orogeny, Central Australia entered a long phase dominated not by tectonic chaos, but by slow erosion and deep chemical weathering. Through the late Mesozoic and early Cenozoic, the interior of Australia sat in warm, humid conditions. Rocks that are today hard and jagged were transformed into thick blankets of soft, clay-rich saprolite, sometimes hundreds of metres deep. Across this softened landscape, rivers wandered more freely and broad. Low-relief surfaces were sculpted by a combination of fluvial processes and hill slope retreat, a process known as planation. One of these ancient landscapes still lingers in the heights of the MacDonnell Ranges, the summit surface, a crest-beveled level around 800 to 900 metres above sea level, likely of Cretaceous age. You can see it in the smooth tops of the heavy tree quartzite ridges near Glen Helen, where ancient north-south valleys were carved across the structural grain long before the modern ranges look the way they do today. This was the high, weathered world in which the ancestral Finke first impressed its course. Later, as Australia drifted northward and climate gradually dried, those deep weathering mantles were stripped away by erosion, a process called etchplanation. As the soft saprolite was removed, the Finke's earlier path became superimposed into the harder bedrock beneath. This is why today's river seems to ignore structure. It inherited a course that made sense on an ancient, flattened, deeply weathered landscape, then cut down into the resistant rocks revealed beneath. By the mid-Cenozoic, a lower landscape level, the shoulder surface, around 600 metres elevation, developed across paths of the Krichauff and James Ranges. This surface is mantled with quartzite gravels, likely a lag left behind as finer weathered material was removed. It is into this surface that both the ancient and modern Finke gorges are incised, making it a critical reference level in the river's history. Nowhere is the Finke's deep time story more spectacular than at the Glen of Palms in the Krichauff Ranges. Here, the river has written over itself like a geological palimpsest. High above the modern channel lies a fossil meander train, an older, abandoned gorge, carved into bedrock when the climate was wetter and floods were steadier but less extreme. Its quartzite gravels were later cemented by iron and silica, forming tough ferrocrete that now stands up as sinuous ridges. This is inverted topography. What were once river bottoms are now mounds in the landscape. Cutting through this relic is the contemporary gorge, deeper, steeper, and more angular, with faceted cliffs and fresh alluvium. The two gorges intertwine like ghost and present river, preserving a rare snapshot of how a drainage system evolves across tens of millions of years. The ancient paleomeanders likely formed under humid Miocene conditions, when flows were more regular and less violent. The modern gorge, by contrast, owes much of its power to rare, extreme quaternary floods that can move boulders, scour bedrock, and reshape the valley in a matter of days. Beneath all this surface drama lies another layer of influence, the slow, subtle warping of the Australian continent itself. Central Australia sits above large gravity anomalies tied to density variations in the lithosphere. These anomalies have caused the land to flex and tilt over millions of years, gently altering river gradients and promoting cycles of aggradation and incision. In the Cenozoic, Australia experienced a broad, north-down, southwest-up tilt as it drifted across the mantle. Only a few hundred metres of vertical change across thousands of kilometres, but enough to matter over geological time. This slow tilting helps explain why parts of the Finke filled with sediment for millions of years before cutting down again. Cosmogenic isotope studies show that some gravels in the paleo gorges were stored for several million years before being re-exposed by renewed incision. The river did not simply cut relentlessly downward, it breathed, filling, pausing, then carving again as the land subtly shifted beneath it. Downstream, the Finke flows across the Missionary Plain, a broad synclinal basin underlain by the Pinjarra Group. Here, the landscape bears the scars of both deep weathering and ancient tectonics. To the west stands Goss's Bluff, the eroded remnant of a 142.5 million-year-old impact crater. Its ring of vertical sandstone ridges is all that remains of a once massive central uplift, preserved because its rocks resisted the same etchplanation that stripped away the softer crater rim. Farther southeast rises Chambers Pillar, a striking remnant of the ancient lateritic landscape that once blanketed much of Central Australia. Its iron-rich cap, mottled zone, and kaolianized core are a frozen cross-section of the deep weathering profile that shaped the region before the modern desert took hold. Like Ayers Rock and the Olgas to the west, it is a survivor of a vanished world. As the Finke exits the ranges, its character changes again. The channel broadens, the valley fills with quaternary alluvium, and the river begins to behave like the intermittent desert system we see today. Hydrologically, the Finke is now dominated by extremes. For long stretches of time, it is little more than disconnected waterholes, but when rare storms arrive, it transforms into a roaring torrent. Paleoflood evidence shows that late Holocene discharges reached at least 5,000 cubic meters per second, with some superfloods possibly exceeding 10,000 to 15,000. These events build massive levees across the Merrick Gully Plain, and carved streamlined bars downstream of bedrock mesas, signatures of megafloods that few rivers on Earth can match. The shift from steady, humid flows to flashy, high-energy floods is crucial to understanding the modern gorge. Under tropical Miocene conditions, the ancestral Finke likely had modest erosive power, carving broad meanders rather than deep slots. In today's arid regime, brief but catastrophic floods deliver orders of magnitude more stream power, slicing downward into bedrock and creating the steep-walled canyon we see today. Eventually, the Finke disperses into the western edge of the Simpson Desert, losing itself among sand plains and floodouts. In wetter quaternary intervals, it likely reached all the way to Lake Eyre via the present-day Macumba River. So when people call Finke the oldest river on Earth, they are not celebrating a frozen relic, they are pointing to something rarer, a drainage pathway that has persisted through orogeny, planation, deep weathering, etchplanation, tectonic tilting, and climate upheaval. It is a river that remembers its past in stone, in crest-beveled ridges, ferrocrete cemented paleomeanders, and intertwined gorges that stack one history atop another. Standing in a Finke gorge today, you are not just looking at a river, you are looking at a geological archive that spans the rise of mountains, the drifting of continents, and the slow desiccation of Australia. In a land often described as tectonically quiet, the Finke quietly records a far more dynamic story, one of deep time, hidden forces, and a drainage line so deeply impressed into the crust that even rising ranges could not erase it. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.